This talk is about 10 surprising things you can do with Webrtc that aren't all just conference calls. We've all been using them a lot, but actually there are other things you can do, and I'm going to talk about what we can do with it, the tricks that we can play to make that work, and some kind of little codey bits to add to that, but to kind of, because we're all developers in this group. And it's all about leveraging web APIs to make users happy. So, very quickly about myself, I'm CTO at Pipe. We're producing a lightweight cleanroom Webrtc implementation from the ground up, no shared code with libWebrtc. And that's targeted at small IoT devices, and you'll see a couple of those things later. I've also got a background in telephony, and I have one patch that went into FreeSwitch, which Tony completely rewrote. But I think it's probably still there. And I currently spend my life writing software at Pipe, but I also spend some time helping produce the standards for Webrtc at the IETF and the W3C. So, as we all know, like 18 months ago, lockdown happened, and that meant that there weren't very many IoT devices being planned and produced. So, like, what should I do? What should I do with my Webrtc knowledge? And I decided to kind of take quite a big step back and build some joy using Webrtc, but trying to make people happy, because we were all a bit gloomy at that point. And so this is basically 10 things I built in those 18 months that we're aiming to make people happy. So the first one I want to start off with is a kid's birthday party. So a friend of mine had an 8-year-old who wanted a party, but it was locked down, so he wasn't allowed to see his friends. But he didn't want to use Zoom because that was what they were using at school, and he kind of didn't want it to be a school party. He wanted it to be a proper party. So we built this thing. Using Webrtc and because it's a standard, there are multiple implementations. So what we did was to build this arena so they could drive droids around and crash into each other, but also have an audio channel so they could speak to each other, but without kind of necessarily seeing each other, because that wasn't necessary. They all knew each other. They just wanted to chat and play and whatever. So they could control up to 6 droids. They're all based on the Raspberry Pi, and they're all running this Webrtc stack. And I can't tell you how much fun we had. I have not laughed that much since, actually. It was such a hoot, and we've done it for a few other people, but the kids were definitely the funniest. And the trick here is that there are multiple implementations of Webrtc, and you can pick the one that suits what it is that you want to do. And kind of on a code front, obviously there's the Pipe implementation, and for this I used that, but there are tons of others out there. You know, there's FreeSwitch, there's Panton, there's Frozen Mountain, there's Janus, there's libWebrtc, stacks of others. So, you know, when you're building a Webrtc thing, go and find the right implementation of Webrtc for you, because it's not necessarily going to be the one that you immediately lay your hands on. So the second thing we built was a yoga teaching app. So yoga teachers wanted to teach their students, but they couldn't get them into the studios. So they wanted to teach them remotely, but they wanted to get the ambience and particularly the high quality music that you expect from a yoga studio. And so we built this thing. Basically, we're using web audio as an MCU. And so we built rendezvous.yoga, and it does an N1S1 stereo mix of all of the users, pseudo stereo mix of all the users into the same audio space, so they feel like they're in a community, in a group. And then we add in music from the teacher's browser, so the teacher is able to inject high quality music into the browser, into the session, and from their browser, and it provides synchronized music to all of the participants. And gives a proper audio ambience for the environment. And we're using licensed music, so the musicians get paid, but it's also kind of tuned for the sensibilities of yoga, and that's from Yogi Tunes. So code-wise, what you're doing here is mixing using web audio in the browser. And all you have to do is create an audio context, take an inbound Webrtc audio stream and wrap that into the audio context, pan that stream to wherever you want them to appear in the stereo space, and then take the other N tracks, the other N-1 tracks, and mix them into what you're going to send back to this participant, and then add the music. And you send that back to this participant. And you do this for all the participants, and you've basically got a really nice audio space, all run from the browser. The third thing I wanted to talk about was kind of home from home, a dollar home, because we needed to access remote machines. And we didn't want to try and go into the office. So we didn't really want to install an app. We didn't want to install TeamViewer or something on a firewall, because that's just too scary. So what we did was to use the data channel to produce what's effectively a remote KVM. And there's a much more detail about this on the Pipe website. But basically what you can see here is Linux running on a server that has no idea this is happening, and then being reflected up, video captured and reflected up onto the Mac, but then in the browser, but then using H.264 for the video and 2 data channels for the low latency mouse and keyboard data. And that gives you an encrypted end-to-end peer-to-peer connection with low latency and zero install, because it's browser based. So I didn't have to install anything to run this. The code trick here is data channel transfer. Now, at the moment, this only works on Safari, but it's really cool. Basically, you can create a worker and create a data channel, and then you can post the data channel to the worker, at which point the data, whatever the data doing and whatever you're feeding it from, is off the main thread. So kind of repaints and other stuff that's going on in the main thread doesn't slow down in this case, your mouse events. And that's really cool. And then the kind of final couple of things is you need to turn off clicks, and otherwise you get kind of weird behaviors, and you need to zap the local cursor, otherwise you get 2 cursors floating about, which is really confusing. So the fourth thing we did was, and this has been a longer term project to be fair, is trusted IoT. So you want a baby monitor, and actually this also got used for monitoring recovering COVID patients, to work with, even if the internet connection to your ISP or the cloud connection goes down. So you want to be able to contain, at least some of the features need to carry on working. The trick here is, and then we all probably know this about Webrtc, is that ICE will find a local path if it's available. And so you can run the real-time audio, video, and data over that local path between the viewing station, which is typically a smartphone, and the baby monitor. And the data stays locally, Stan, if that's possible. But it's still encrypted end-to-end. So even if you've got kind of weak security on your LAN, then on your Wi-Fi or whatever, it's still encrypted end-to-end. And you want, as I said, you want the key features to carry on working even if the ISP goes down. Unfortunately, this is a little bit difficult to do on pure web, but you can do it in native apps. So the trick here in the code space is that you need to create the offer in and on click, and also having got user media. If you don't do that, then Safari in particular blocks handing out the local address candidate. So you need the mic and cam permissions first, and to do that you need a user gesture. And then once you've done that, what you'll get back from Safari is a candidate that's an MDNS candidate. So it's random string.local rather than an actual IP address, but you can still use it. And then you can pass that to the device, which can then reach you on the local network. The fifth thing I wanted to talk about was spreading the love. And this is kind of a conference-centric issue, actually. So conference venues are booked typically years ahead. And so, if you're a conference organizer, then you have a queue of, you want to try and get into a queue to book a site many years ahead. And to do that, you go and visit it a few years in advance. But of course, nobody's traveling or weren't traveling. And so we needed to produce a way of doing virtual site visits to help secure that sales pipeline so that, you know, when people are back traveling, this is still possible. So the key thing we wanted to do with this was, and this is HiBab app, is to make these virtual site visits from a composite series of video sources. So there'll be the people who are on the site visit, so the, you know, kind of Brady Bunch picture. There'll be static images of the city or the hotel or whatever. And there'll be video clips that are of the city or of previous events or whatever, pre-produced videos. But they're also guided, flown VR tours through the hotel or through the conference venue. And we need to switch between them in a really smooth way so it's not kind of glitchy. And what we do for that is replace track. Now, I was a kind of late convert to replace track, but if you've already got a video stream running and you want to replace it with another source of the same kind, you can do that, and you don't have to do an off-ramp round trip. So instead of having like a 150 millisecond round trip before the video changes, you can change it really fast. All you have to do is find an active sender of the same media type. And then if there is one, you can just replace the track with the new one that you want to send. So you might replace a video conferencing session, a mix of videos with a static image or whatever your combination is. If there isn't an existing track, you have to add one. So what you're effectively doing there is something quite like an SFU, but it's in the browser. It's in JavaScript in the browser. So the sixth thing was connecting the SHI. Not everybody wants to install your favorite video app. Right? They might want to see your face, but they don't necessarily want to buy an Apple device in order to talk to you on FaceTime or whatever. So the trick here was that we used SMS to facilitate that. So we create a video call app in the browser, but using SMS as the trigger for connecting the calls. And obviously that means that because it's cross-browser, you can do that across ecosystems quite easily. And there's obviously no setup, there's no install, and we made it free to use because we don't have any server costs for it, so we just kind of threw it out there. It works on all smartphones, and a little trick that we did for this, we found that there's a particular age group, and I'm in it, don't particularly like seeing themselves. They find it distracting and disconcerting. And so what we ended up doing is a fake reflection, as if you're looking through the glass. So there's like a 5% translucency on the self view. And the code for that is basically using CSS. You take the self view and you place it next to the remote view. Use the CSS to make the self view transparent, and then you translate it so that it overlays. And then you need to do a little tweaking with the aspect ratio in order to make sure that, like, if one of them's in portrait and one of them's in landscape, things still roughly line up and still give a clue about where you are in the screen. Because actually all you want from the self view is to make sure you're reasonably well centered. You don't care about, like, the detail of it. So the seventh one was Cozy Space. This is a simple, free audio and video space for kind of hanging out. The specific example was a book club. So, we'd had a book club that had been meeting before the pandemic, and we kind of wanted to keep meeting, but we wanted to preserve the atmosphere of the room. And one of the things about that was that we noticed that things like Zoom, when somebody laughs, the video flicks to them, and also quite often the audio cuts out from the person who's actually speaking. And so, or if somebody shuffles in their chair and it creaks, then the same thing happens. And you get this kind of very, you feel a bit self-conscious about, like, even moving in that environment. So we wanted to get rid of that. We wanted to get rid of, we didn't want sign-in, we didn't want costs, and so we wanted to use our own bandwidth to do this. So we basically used the canvas in JavaScript as an MCU. So we take the inbound video tags, the host takes the inbound video tags from all of inbound video from all of the participants and plays them into invisible video tags. And then requests frame updates from those video tags. And on the request frame update, you paint that onto a canvas, but you shift them over so that they're spaced out across the canvas in the layout that you want. And then you capture the canvas and you send that back to the users. So you end up with what is effectively an MCU, but it's happening in the browser. The other thing we wanted to do, and I'm a podcaster, is to have deep, meaningful chats. And we found that podcasters couldn't get guests into their studios where they could get the kind of real high quality audio of the studio, but there were many important stories we still wanted to try and tell. And so what we noticed was that the microphones on mobile phones are just great these days. And everybody's got a mobile phone with decent microphones. And they're particularly good for voice because that's what they're tuned for. So what we basically do is built a Webrtc app that you send a URL to a guest and they open it on their smartphone. They just need to be in a quiet room and have decent internet connectivity, and you can interview them really easily and in a very natural way. We've done 60 or so interviews like this on Distributed Future, and they're generally pretty good. So the code for this is basically the trick of the code is to use Media Recorder and Opus. So we take the guest's inbound audio stream, pan it, in this case to the right. We create a media recorder. We take our own audio, local audio, which we're obviously sending to the guest, but we also take a copy of it and pan it to the left. We mix the two of those together and plug them into the recorder. And then the recorder captures the data into chunks. And at the end of the session, we save that to an OGG file. And then we can then post-process that and put it onto the podcast. The ninth one is phoning a friend. So what we found was that sites want to limit access to video, particularly live video, because you've got to all these Zoom bombings and stuff. But usernames and passwords are a real bore, and particularly with a kind of group that meets regularly. Like logging in every month to the book club is a nuisance. You shouldn't need to do that. And cookies are clumsy as well these days. So what we basically do is the trick here is trust on first use, which isn't like a new thing. People have been doing this for ages. So basically you do your tests on the first use, and then you create a token and you persist it such that the next time you don't have to do those checks because you just see if the token's there. And there's some added magic here, which is that we can use that token to check whether it's genuinely peer-to-peer and detect a monster in the middle. So we know that nobody's intercepting that or adding to it. So the trick here is using two features of Webrtc and XDB. So the features are that you can create a self-signed certificate in the browser. So there's a call to create a self-signed certificate in the browser where you can actually set the expiration time on it. And you can use that certificate as part of the initialization of a peer connection for Webrtc. And then so the recipient of that can check to see if the SDP offer has the fingerprint that they're expecting. And that works first time, but the really sweet thing is you can persist that certificate into IndexedDB and then retrieve it next time the user logs in a month later. Next time the user visits the site a month later, you can retrieve from IndexedDB that certificate and use it. And then the far end can retrieve the fingerprint from IndexedDB, compare, knows that it's the same user as well, and it doesn't need to do any checks. So my final thing is, I guess you've probably all noticed, but QR codes are everywhere these days. And there used to be kind of quite a lot of resistance to them, but they're pretty socially acceptable these days. And they're a great way of getting people into Webrtc experience, particularly for second screen apps. So if you've got like kind of some sort of video app running on a big screen, but you want people to join maybe the audio on their smartphones or something, then you can use a QR code to do that. And I'm now going to take a kind of a huge risk and try doing exactly that. So what I'd like you all to do is get your phones out, and I'm going to share a QR code with you. So what you're going to see is the video streaming from actually not this camera, but a little IoT camera, and a QR code next to it. So with any luck, you should see another view of me from this camera and some QR codes, a QR code. So I'm asking you to show that to your smartphone camera and allow it to browse to that URL, and you'll see that when we hit 21 viewers, I think we'll time out. Yeah, we've got to 11. Keep coming, keep coming. I think I've maxed this out at 21, because after that I start running out of bandwidth out of my VDSL here. So when we get to 21, yeah, 20, one more, I think. Yeah, okay, good, excellent. Thanks, folks. 22. Ooh, that's a surprise. Right. Oh no, I think it's kicked you out. Yeah, it's gonna hover between 21 and 22 and kick you out. Right, cool. So you're welcome to watch this view of me or not. It's entirely up to you. But I'm going to go back to my slides. And the slides. Yes, excellent. So yeah, so I got 21 people on in a few seconds, which is actually kind of interesting. Oh yeah, there we go. Demo time. One to many with no server. So that's the subtle thing here, right? What you've just seen was live video to 20 plus users from a modified IoT camera. So it is an IoT camera, but it's not running the stock firmware. Obviously, it's running firmware that I've produced. But I'm just using my VDSL to do this. It's not kind of going to a central server anywhere. There's no cloud processing. There's no media server in the middle. It's all done on the device. Effectively, the device is acting as an SFU or a fan-out device at any rate. And there were no central permissions. Like there's no certificate store in the middle. There's no user list in the middle. Or the device made its own choices about who it was prepared to allow to view it. And I think you can expect to see this kind of edge-based solution for smaller, like 10 to 20, maybe even 50 groups in things like webcams, but also in routers. I think you could see something that looks a bit like Jitsi or Cantina, cut down, the limited scope, but running in routers in the not too distant future. Because I think that we've all got enough bandwidth to do that at the edge. And actually, it turns out that that was true for all of the apps that I've just shown you. Not a one of them had a central server. They were all edge-based apps using their own bandwidth at the edge. And so I don't kind of hit AWS costs or anything like that, which allowed me to experiment kind of freely. But also, now this is arguable. I know people who disagree with me on that, but in most cases, I think it gives you lower latency. And it gives you better privacy. And it means that the cost of customizing this for a niche app like a book club isn't ridiculously high because it's decentralized and at the edge and all in the browser. But I was very careful to choose tricks and code that's relevant to all the other apps, so all the other spaces. So, all of those tricks that I've done are actually relevant if you've got a server-based solution, because I understand there are a ton of apps where you need a server-based solution, like what we're doing now, for example. So here's some contact info. The slides for this will be on the Pipe website, and it will also, I presume that the ClueCon folks will distribute them when I get around to putting them up and sending them around. And I think I have like half a minute for questions, if that's of interest to people.
Thank you so much, Tim.
Go for it if anyone's got any questions.
Well, looks like Dave has a question. Oh, no, I'm sorry. Dave just wanted, he said a great variety of apps with a live working demo. And I love your demo. So this was the second time I was able to watch it, and it impresses me every single time.
So the thing that I just want to like say a little bit about that demo. What is really surprising is that no servers were harmed in this. Like, you know, you're literally running on this thing, and I think on this flat in here in Berlin, I get 44 megabit uplink, which is enough to do 20 people's video streams and carry on presenting and carry on speaking, like all on my, what is I pay a month, 30 euros a month or something.
So do you see the future
new,
of, the future of like baby monitors or like in-home networks moving something to this, or do you think it will affect?
Yes. So I think there's a bunch of usages where you really want local things to work. Like you want the baby monitor to carry on working even if your uplink goes down to the ISP. Yes. You want your security cameras to carry on working. Now, there are things you want to be able to do, like you want updates to come from the cloud. There's a bunch of stuff that you want to come from the cloud, but there's some core functionality which you don't want to have dependent on the cloud. And let's be honest, there's a bunch of users of companies who don't want that data. Like if you're like, you don't want to be sitting on a gold mine of people's baby pictures. Like as a company, it's a big liability sitting on that data. And so, you know, it's a win-win. And I speak from Berlin, where privacy is a bit more of an obsession than in some other places. But like, you know, we do really care about it here. And so like, I think the privacy benefits play out as well.